Hello, my name is Margaret. Today we're going to discuss real zeros of polynomial functions. Let's look at our objectives for today. First, we'll look at division of polynomials. Next, factoring polynomials. Graphs and multiple zeros. And finally, rational zeros. So let's begin with a problem involving division. We're going to divide 3x cubed minus 2x squared plus 5x minus 8 by 2x. In this example, we can divide each term of the dividend by 2x. So we have 3x cubed divided by 2x minus 2x squared divided by 2x plus 5x divided by 2x minus 8 divided by 2x. Now we can reduce, giving us 3 halves x squared minus x plus 5 halves minus 4 over x. This is much like short division in arithmetic. Now let's look at a problem that's similar to long division. We'll divide 4x cubed minus 2x squared plus 4x plus 1 by x minus 2. And we'll set this up just as we would a long division problem. So we'll write our dividend again. Now we ask, how many times will x divide into 4x cubed? Well, x divides into 4x cubed 4x squared times. And we'll multiply each term in our divisor by 4x squared. So this gives us 4x cubed minus 8x squared. Now we want to subtract. 4x cubed minus 4x cubed is 0x cubed. Negative 2x squared minus negative 8x squared gives us a 6x squared. And we'll bring down the next term. X divides into 6x squared 6x times. So we'll put plus 6x in our quotient. 6x times x is 6x squared. 6x times negative 2 is negative 12x. And we'll subtract. 6x squared minus 6x squared is no x squareds. 4x take away a negative 12x gives us 16x. And we'll bring down the next term, plus 1. X divides into 16x 16 times. So we'll put 16. 16 times x is 16x. And 16 times negative 2 is negative 32. And it will guess we'll subtract. We have 16x minus 16x is 0. 1, take away a negative 32 gives us a plus 33. Now, there is a way that we can do division, long division, that's a little bit easier than this, and that's called synthetic division. Let's take a look at an example involving synthetic division. We'll use synthetic division to divide 5x cubed minus 3x squared minus 7x plus 8 by x minus 3. Now, we are going to work with the coefficients in this expression. 5, negative 3, negative 7, and 8. And we'll put those in a row. Now, if you have terms that are missing powers of x, you will have to use a 0 in place of any missing powers. Now, we're dividing by x minus 3. We're going to put this 3 out here. Synthetic division says bring the 5 down, multiply 3 by 5, this gives us 15, and put it under the next number in our row, top row. Now add these two together. This gives us 12. 3 times 12 is 36. We'll put the 36 under the next number in our top row and add. This gives us 29. 3 times 29 is 87. And again, we'll put it under the next number in our top row and add, giving us 95. The numbers that we have gotten here give us the remainder plus the coefficients of the quotient, starting with the constant, which is 29, the power of x, or the coefficient of x to the first, which is 12, and the coefficient of x squared, which is 5. So our quotient is 5x squared plus 12x plus 29 plus our remainder of 95 over our divisor. Using synthetic division enables us to complete the division problem much more quickly. Now we'd like to talk about the factors of a polynomial function. In order to do that, we're going to look at two theorems. The first is the remainder theorem. If a polynomial f of x is divided by x minus k, the remainder is f of k. The factor theorem, a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. Now, using these factors together, or these theorems together, we can find the factors of a polynomial function. Let's look at an example. We're going to use the following graph of f of x equals x cubed minus 2x squared minus 5x plus 6 and the factor theorem to list the factors of f of x. Here's the graph of our function. Notice that we have x-intercepts at -2, 1, and 3. Now remember what that says, that f of -2 is equal to 0. F of 1 is equal to 0. F of 3 is equal to 0. By our factor theorem then, this says that x minus a minus 2 is a factor. Let's write that as x plus 2. That x minus 1 is a factor, and that x minus 3 is a factor. So our function, f of x, can be factored into x plus 2 times x minus 1 times x minus 3. Now, suppose that we have this problem. We want to write the completely factored form of the polynomial f of x equals 2x to the fourth minus x cubed minus 13x squared minus 6x, given that c equals -2 is a 0. This problem gives us 1 0 of our polynomial function. But there's another one that's evident. Notice that all terms in this function have a factor of x. So we should first factor that x out. When we do, we have f of x equals x times the quantity 2x cubed minus x squared minus 13x minus 6. Now we know that c equals -2 is a 0 of our function. Therefore, it is a 0 of this polynomial factor. Let's use synthetic division here and find the other factors. The coefficients here are 2, -1, -13, -6, and c equals -2 was our 0. So we'll bring down our first coefficient 2, our constant, our coefficient there, multiply by -2, we get -4. Put the -4 under -1. Now let's add. We'll have -5. -2 times -5 is 10. We place the 10 under the next number, -13, and add. That gives us -3. And -2 times -3 gives us a +6. We put the 6 under the -6, and the sum of the two is 0. Again, the value of this polynomial at -2 is 0. The 0 remainder tells us that this is the other factor. So f of x is equal to x times x take away a -2 times 2x squared minus 5x minus 3. The only thing we need to do now is to see if we can factor this quadratic expression. F of x is equal to x times x plus 2 times, we'll have 2x and x, we'll have a 3 and a 1, a plus 1 and a -3. So we have succeeded in finding all of the factors of this polynomial function. Here's another example. The polynomial f of x equals x cubed plus 3x squared minus 4x minus 12 has a 0 of -3. Express f of x in completely factored form. Now I'd like you to try this problem yourself, so please stop the tape while you try this. Let's see how you did. Now we are told that x equals -3 is a 0 here. So using synthetic division, we'll write down our coefficients: 1, 3, -4, -12, and we'll put -3 here. Bring down the 1. 1 times -3 is -3. Add, we have 0. Put the 0 under -4. -4 plus 0 is -4. -3 times -4 is a positive 12. Add again, we get 0. So far, we know that f of x is equal to x take away a -3 times this quadratic expression. Now remember, this is the constant -4. 0 is the power on x, the coefficient of x, and 1 is the coefficient of x squared. So we have x squared minus 4. Now, f of x is equal to x plus 3, and we can factor x squared minus 4 into x plus 2 times x minus 2. Sometimes a factor in a polynomial will occur more than once. If a factor occurs n times, then the 0 we get from that factor is said to have multiplicity n. Here's an example that'll show us that. F of x equals x minus 3 to the 5th times x plus 4 to the 6th. We have two factors here, two distinct factors, and therefore two zeros. The 0, 3, is said to have multiplicity 5 since it occurs in a factor whose power is 5. The 0, -4, is said to have multiplicity 6 because it appears in a factor whose power is 6. Now there is also a connection between the behavior of a graph and a 0 and its multiplicity. Zeros and multiplicity. If a 0 of a polynomial f of x has odd multiplicity, then its graph crosses the x-axis at the 0. If a 0 has even multiplicity, then its graph intersects but does not cross the x-axis at the 0. The higher the multiplicity of a 0, the more the graph levels off at the 0. Well, let's take a look at a problem. Suppose we'd like to graph f of x equals x minus 2, the quantity cubed, times x plus 4, the quantity squared. Now, we have two distinct factors, therefore we have two zeros. The 0 of 2 is in a factor whose power is 3. The multiplicity of 2 is 3. Therefore, the graph crosses the x-axis at 2. Our second zero is negative 4. Its multiplicity is 2 because it's in a factor, or comes from the factor, whose power is 2. This means that the graph touches the x-axis at negative 4 but doesn't cross it. Let's put this into our graphing calculator and see what the graphing calculator tells us. So we have x minus 2, the quantity cubed, times x plus 4 squared. Now, we're going to have to use a different window here. Let's try negative 5 to 5 on the x-axis and negative 300 to 100 on the y-axis. And here's our graph. Now, we see that we do have an x-intercept at negative 4. The graph just touches at negative 4 because the multiplicity, remember, of the factor x plus 4 was 2. We have a 0 at x equals 2. It does cross the x-axis at 2 because the multiplicity of that 0 is 3. Now, there are times when we need to find our roots and we have no idea where the roots might be. If we have a polynomial function, we have a test that we can use that can help us at least list the possible roots to a polynomial function. That test is called the rational zero test. Let f of x equal a sub n x to the nth plus plus a sub 2 x squared plus a sub 1 x plus a sub 0, where a sub n, different from 0, represents a polynomial function f with integer coefficients. If p over q is a rational number written in lowest terms, and if p over q is a 0 of f, then p is a factor of the constant term a sub 0, and q is a factor of the leading coefficient a sub n. Let's take a look at this example, and we'll use the rational zero test here. Find all the rational zeros of f of x equals 8x cubed minus 42x squared plus 7x plus 15. Now, p, remember, consists of any factors of the constant. Now, the factors of 15 are 1, 3, 5, and 15. So p can be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Q would be a factor of the leading coefficient. That's 8. Now the factors of 8 are 1, 2, 4, and 8. So possible values for Q are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now, what are the possible choices for P over Q? Well, we have quite a few. Certainly, all the numbers for P, values for P divided by plus or minus 1. So that gives us plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. All the values for P divided by 2, plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, plus or minus 15/2. All the values of P divided by 4, plus or minus 1/4. Now, plus or minus 2/4, excuse me, that's not right. We have to go to 3/4. Plus or minus 3/4, plus or minus 5/4, and plus or minus 15/4. And then lastly, we have to divide all the values for P by 8. So we have plus or minus 1/8, plus or minus 3/8, plus or minus 5/8, plus or minus 15/8. So we have a lot of choices of possible rational roots or zeros here for our polynomial. Now, I would like to factor this, and I'm going to choose a value here that I know is a rational zero for this function, and that value is 5. Let's again write our coefficients of our polynomial and our 5, and we'll use synthetic division. Bring down the 8. 5 times 8 is 40. We'll add negative 42 and 40 to give us negative 2. 5 times negative 2 is negative 10, and we'll add to give us negative 3. 5 times negative 3 is a positive 15. 15 plus 15, or minus 15 is, I forgot a negative sign. Negative 15 gives us 0. So we know that f of x factors into x minus 5 times 8x squared minus 2x minus 3. Now we need to try to factor this expression here. It's a quadratic, so we'll set up our form here. And let's try 4x and 2x. The only factors of 3 are 1 and 3. Suppose we put 3 here and 1 here, and we'll put our negative and a positive. Now check your multiplication to make sure it's correct. Our outer product is 4x and our inner product is negative 6x, so that does give us a negative 2x. So we have completely factored this polynomial. Now we wanted to find the zeros, remember, so we have to go back to each of our factors to find the zeros. If x minus 5 is equal to 0, then x is equal to 5 is a 0. If 4x minus 3 equals 0, then x equals 3/4 is a 0. And if the factor 2x plus 1 equals 0, then x equals negative 1/2. Well, today we've talked about finding the zeros of, or the real zeros of polynomial functions. We've looked at synthetic division to help us. We've looked at the remainder theorem, the factor theorem, and the rational zero theorem. Make sure that you practice your techniques here by doing all the homework your instructor assigns. Have a good day.